All right. Thank you, Tiernan. Hello, everyone. I'm glad to hear that we've got such a great group of people on this morning and afternoon, I guess, depending on where you're at. And I would like to, first of all, just thank, I'm going to try to bring this up here to full screen. And I would like to thank the AMS, especially for allowing us this opportunity. And it looks like I'm going to back up here. There we go. This opportunity to talk about our interests and our projects. And so I want to talk about this idea of observation to contribution, which is, I think, where we're all trying to go. And we saw a lot of that yesterday with people making observations and then how those observations are actually used. And this is becoming and has been quite important for some time. So I'd like to focus a little bit on citizen observations and mesoscale weather. We were talking about what got people interested in weather. I can remember when I was a child waking up in the middle of the night at a lake house in Wisconsin, and we would get these huge thunderstorms in the middle of the night. And I didn't know it at that time, but these were actually mesoscale convective systems. In some cases, they were very high wind producing systems. They might have been bow echoes. I remember seeing the waves on the lake and it was all sort of scary, but it was also kind of interesting to me. And that sort of propelled my interest in thunderstorms and especially mesoscale weather. So as a kind of a quick outline of what I'm going to talk about, of course, citizen weather data, where does it come from? I'd like to talk a little bit about case studies in particular, and I'm going to give 3 examples of case studies where I've been part of that or worked on a project with that, and then finally talk about what we might do next. I think that's where I want to get to here, is really talking about what other things might we do and maybe stimulate some conversation. So again, my purpose here is really to show how enthusiast observations can add value. And I think, we've already seen a lot of that yesterday, and I'm sure we will more today. Jim's talk about CoCoRaHS was, perfect segue into what I'm going to talk about, because there's a lot of CoCoRaHS in this also. And I think that in particular, I want to focus on these sort of isolated, maybe somewhat unusual and challenging weather events, and then maybe stimulate some further discussions on what we might do to encourage collaboration between the enthusiast and professional communities. So here's just a little pictorial diagram of a lot of what we talked about yesterday, with many different sources of citizen observations. CoCoRaHS is certainly one of my favorites. I've also been involved for a number of years now with that, and it's amazing how fast we accumulate observations. I think I'm over 4,000 now, and I've been in 3 different states with that. So I've had to learn how to measure snow a whole lot better here in Minnesota. In Texas, that wasn't much of a concern when we were there. And there's, of course, many other sources of information out there that we're all looking at. These things can be used for all kinds of different purposes. We've talked about, using them for forecasts and forecast improvement. They can be used for training photos and videos. I know I've seen the Weather Service use some of this in Skywarn training, climate databases, drought monitoring, heat monitoring. We saw some of that yesterday, and certainly different kinds of research. What I'd like to focus on again here is what I call case studies. And case studies are defined in some ways, both in the AMS glossary, and also I like David Schultz's book on eloquent science. He has a little definition in there, and he talks about some of the advantages of case studies. We're all familiar probably with some of these big field campaigns like the BAMX or the Pecan, where they have these they produce these large data sets that they collect, and they can study particular events to gain a better understanding, and then ultimately forecast these better. So I think we can improve our understanding through the data. Obviously, citizens don't or usually can't contribute on the level that we do with a large field campaign, but I think we can certainly provide some information and details that can help the efforts. And so they can be a very effective scientific tool, as David points out. And I think we can enhance the details and also even in some cases point out some of these events that might have been missed otherwise. And I'll talk a little bit about that. Here, there we go. All right, so the first example I want to talk about is this mesoscale convective system with heavy rain. This was a type of mesoscale convective system that produces a training line, and most of us are familiar. If you have training of thunderstorms, you get very heavy rain totals in isolated areas, and that's what happened in this case. So Angie, this actually occurred in part of your territory there in Iowa. This particular one was back around Labor Day in 2020. We happened to be on a lake house, and some of our activities were delayed that day, let's say, by this MCS, which had actually occurred in the overnight hours and then produced some rain and wind that lasted into the next day. But basically, we were off on sort of the fringes of this. The part that took the really heavy rain was in Iowa. And this type of a system is pretty well known. These systems have been classified. There's some really nice papers about it. Russell Shoemaker and Richard Johnson have written a nice paper where they classify these. And these are sometimes referred to as training line and adjoining stratiform precipitation, MCSs. So looking at the forecasting and what made this event kind of unusual, there were very heavy rain totals. What I liked about it, I looked at the Weather Prediction Center's quantitative precipitation forecast, and you can see here, 48-hour forecast actually was remarkably well done when you look at the CoCoRaHS and you compare the observations, which is what I had done here, and then compare that to the original forecast. There was a little bit of a problem though, and there's a challenge here at the high end, especially. The forecast from the Weather Prediction Center actually called out about 2.5-inch maxima, whereas we actually observed about 5 inches in some of these, which I'll point out here in a second might have been missed. And so this is a great example of how CoCoRaHS can bring forward data that might have been missed otherwise. And I included both CoCoRaHS and the co-op, the National Weather Service co-op observers together here. I sort of put all that together for a 10-county area in Iowa where this storm had the greatest impact, the largest amount of rainfall. And you can see there in this graph, I sort of plotted that out on a histogram. And actually, if you look at just the areas that were greater than 3 inches, which was above what had been forecast in the quantitative precipitation forecast, 94% of those observations, 16 out of 17, were from volunteer observers, and many of those were CoCoRaHS observers. So a very important source of information, and those 5-inch totals, which were especially remarkable, would have been totally missed if we didn't have the CoCoRaHS and volunteer observers. So the next event I want to talk about is this convective wind event. This was a what I'll call an isolated event. It was a high base convective event. And you can see down on the lower left there, I put an arrow to the area where these wind reports occurred from this is the map from the Storm Prediction Center database. And you can see it was sort of isolated and was outside of the risk areas. So these type of events are very difficult to forecast without, as Steve Corfidi said, over forecasting, because it's it's possible that they would try to produce forecasts for everything, and then of course we sort of get a cry wolf sort of an effect where everything is sort of over forecast. So there's a balance here that the forecasters are trying to reach. But I think sometimes it could be interesting to look at these events that are sort of isolated and unusual and see what we can learn from those. I happen to be visiting family in Northern Illinois during this time. And so I was right there, kind of had a front row seat to this. I took the picture there in the upper right where you could see these high base cumulus clouds forming, and they kind of caught my eye. And it wasn't too long after that we started to get some very high winds. Unfortunately, I didn't have an anemometer with me. I would have tried to take some measurements, but there were wind reports in the storm database around Northern Illinois and Southern Wisconsin that were 58 and one as high as 63 from a member of the public. So there again, people in the public contributing data, and the two airports with official observations actually confirming that. So these were technically severe limits, had reached severe limits with the wind. It was an interesting event, and I shared this on the AMS community page, and the professional community was actually really great in coming right back with some comments on that. And I mentioned Steve Corfiti was especially helpful. He came back and wrote a very nice analysis of this, not comprehensive, of course, but we did do some analysis, and it was great because he pointed out some interesting resources that to go back to, references to read. Basically, this occurred in an environment with an inverted V sounding, which is more common in the western part of the United States. Sort of like the dry microburst environment that Roger Wakimoto has written about, and then something in between that and a more strongly sheared environment where we get mesoscale convective systems. And you can see in this radar picture in the lower right that I pulled as this system was moving through Northern Illinois, you can see it sort of almost has characteristics of a mesoscale convective system, but the individual cells are sort of isolated and not quite that organized. So again, another interesting event that I think the professional community really took some information that we had here, a little vignette, I like to call it, of the case, and they were able to add something more to that so we can all understand it better. And then this is sort of my final example here, was a convective hail event. And this one I sort of, again, I had kind of a front row seat. We were out watching the storms. We were storm chasing. We were following this particular storm. And you can see with the arrow there on the picture on the left that we actually were, it was rather isolated. Again, it was outside of the normal risk areas. And again, these sort of things are very challenging to forecast. I think there was some verbiage in the Storm Prediction Center text about the possibilities of this. But you know, this was sort of an isolated event. And you can see in this, I'll show this little video here on the right, how this storm progressed. You can see there where the arrow is and the dotted line, it just sort of follows that. And it may have actually been more than one storm. At one point, it looks like there's almost a merger there. And then as it develops and moves south, it almost forms sort of what I call a mini MCS. And it gets a little more organized. But all during that track, it was over 100-mile track that this storm took, was kind of unusual, and it dropped hail during that time. There was a number of good CoCoRaHS observations that talked about, if you read the notes, which a lot of people were so good to write, and they really told you about what they saw and the size of the hail. And there were some hail reports that were pretty significant, over 1 inch. So I think that this was an example, and I did a little bit of analysis thanks to some of the tools that are available online. You can see here how the storm, one of the reasons the storm maintained itself so well, it seemed to maintain sort of an inflow-outflow balance. Apparently the environment that this was growing in was balanced in terms of its its shear profile, and the storm was able to maintain itself. There were times when there was rotation in the storm, and we could see that. I mean, see that here, sort of broad rotation in the lower right there on the velocity image. That was about 5,000 feet when I looked at the distance from the radar. You can see a little bit of a hook there in the upper right base reflectivity image. And then the picture on the left corresponds to that same time when we were actually out there watching the storm. You can see a little bit of you see the wall cloud and a little bit of a clear slot coming in. So at that moment, it was almost trying to be supercellular. And I think the storm sort of evolved through various phases. So these kind of events can be sort of interesting to study. And again, they are sort of challenging to forecast the exact time and place. And we can probably learn some things from that. A little bit on the hail. We were actually close to the hail. We got a little too close to the hail at one point. And we did thankfully not take any damage to our vehicle, but we were close. So use that as an opportunity. We actually stopped, and I was able to gather some of the hailstones and do some measurements. And it's not a huge data set. I only had 17, but I was able to run some numbers on that, and using some statistics, inferential statistics, you can see, if there's a normal distribution, and that's kind of an assumption, but if there's a normal distribution of hailstones, then there should be a certain percentage that are even larger than what we measured. So I thought that was kind of cool. And that's one way, not always so easy to get, because sometimes it's hard to collect and measure a large number of hailstones. It's usually hard to do that. But when we can, it kind of gives us some information about what the storm is actually producing and how large are the larger storms. Our observers see certain things, but maybe there's things that are happening out there that we can't observe. So in conclusion, I think, the case studies, I think, are certainly an effective way to learn about weather. And there's many of those in the literature. The National Weather Service provides a lot of those on their websites and others. And so I think enthusiasts, as I've tried to show here, can certainly provide some valuable information and observations to that, especially to help on the mesoscale level. And I think collaboration between the communities, professional and amateur or enthusiast, can be very helpful. And so, I'm kind of proposing here that one path forward might be that we talk about creating some sort of a portal where some of this could be shared in a more formal way, where people could write comments and talk about specific cases, starting out with sort of a vignette like what I've showed here. Here's a sounding, here's what we saw. What do you think is going on here? And then we all sort of collaborate and contribute to that. It's kind of like what happens with the National Weather Service news headlines. They have a really nice, many of the weather service offices do this, particularly on significant weather events, to sort of explain what was going on, understanding the causes a little better. So that might be kind of a model for what we might be able to do here. So I hope that maybe that'll stimulate some conversation, and we'll talk about this some more. I'd like to thank all those that I've mentioned, especially CoCoRaHS volunteers who provide so much information and data. The NOAA Storm Prediction Center, of course, and all the things that they provide. The National Center for Environmental Prediction provides some great tools like that radar that I was showing you, some great tools to work with the radar data, enormous database that you can work with there if you're interested in studying something in particular. And then, of course, I want to thank Steve Corfiti, who was so kind to take some time and give his thoughts on this, do a little bit of analysis, and even look over my presentation. I thought, well, it's a good idea, since we're talking about professional and amateur collaboration here, it'd be a good idea to do some of that. And he's so kind to take his time and do that. So again, I want to thank you for the time here this morning and this afternoon. And please feel free. I'd be glad to entertain any questions.